Hi all, welcome to my tutorial. I think it's been a while. I have posted this any video in my channel. So I'm going to start a new playlist with Python. So today we're going to discuss an important interview question for Python. So I think it's most asked question. So it's about rotating the list kth times, so from right to left or left to right. So that's the solution that we're going to discuss now. Will also be helpful if you get a question like how to rotate a list from left to right also. So for this video we are just going to see how to rotate a list of elements kth times from the right to left. So there are many brute force solutions here, which you will find in the internet, like rotating through the list of elements. And the first, uh, let's say the length of the list is L. So the list L here. So only rotating till the number of times, the length minus the K, and again appending to that list this elements like so that kind of brute force elements. There are several brute force ways where you have these solutions, but now here we are going to discuss a pure Python solution where it's very much easier and optimized solution. So okay, let's get started. Yeah, so if you see here, so the main question here is to rotate the elements of the list from right to left, so k times. So that means that if we are given a k equal to 1, so our list will be like this. So we will be having an element which is the 7, so that from right it gets shifted to left. That means it will be here and look like this. So if I have a k equal to 2, that means I have to do 2 times rotations. That means I have already rotated the 7 once, and if k is 2, that means I have to rotate one more element which is 6. So that element, if I rotate here, so it becomes like this. So similarly for 3 also, if I do the same thing, so if I do the 3, I will be shifting this 5 to here, which becomes my array. So if I do the same thing for 4 as well, so for 4, so I have to shift the fourth element here, and this is how it looks. So this is how it was the logic. Hope you understood this one. So our main intention is to write the logic to rotate these elements. So I'm going to give a simple one-line single solution using the list indices. So here we are just going to select the elements what we require. So the solution is very simple. We just have to have a result. So the result of the list is uh, a rotated list k at the times. So we are going to take this k as reference here. That means we are going to select, so we'll take the list, so we'll select the elements. So if you observe here, so we take the list, and like when we rotate it, the last element, the k elements are shifted to the left side from the right side. So if I say k equal to 2, that means that my last two elements are shifted to the left from right. So we are going to use a similar logic here. So that means like we will be selecting only the required elements, for these two elements. So we will be selecting only the elements which we need here. So okay, so I'm going to select only the two elements from the last, so which means that I have to select only two here, and so I will be so what I will do here is I will just select all. So from here I will just select only the two elements. For example, let's say we are given it, let's k equal to 2. So I'm going to, for example, I'm just taking k equal to 2, and so use that here. So I will be selecting all the like only the two elements from the last, so that because I need them in the front, so I will be selecting only two elements, and those two elements are also not the starting elements, they are the last elements. So for this we have to use the list indexing. So here I am going to select, So yeah, I'm going to select these two last two elements. So the last two elements, why last two elements is because we have the k equal to 2. If I have k equal to 3, I will be selecting last three elements. So let's say, for example, this k equal to 2 here, and I will be using the k here. So I will be indexing with the negative k here and selecting all. So this is because, so I am selecting k, okay, so and the negative index, which means that, so I will be selecting from the last. So this is -1 and -2, and from here I will be selecting all the elements way to right side, which means that I will be selecting 6 and 7 as well. So once I select them, so that means that I got 6 and 7 here, and then I have to select the rest of the elements, which are this one. That means I have to concatenate this list with the one more list, which will select the first uh, the remaining elements. So here we have 6 elements, so the remaining elements are the first 4 elements here. So which is very simple, we'll be selecting all the elements all the way to minus k here. Yeah, so this is our simple logic here. So let's just try this in our reactive Python here. So I pasted this one here, and yeah, hope you can see it now clearly. So when I say list k off, so when I select only the elements from the last, so I will get yeah, so k is not defined, of course. So yeah, so k equal to 2 here. So if I say k, yeah, so I will get last two elements. If I do the same here, so to select only the required elements, so that means I will be getting the the excluded elements, the first 2, 3, 4, 5, and so if I concatenate both of them, if I do minus k and sorry, L, oh, it's k. So if I do this, sorry, plus. So yeah, so this is my list that has been rotated k number of times. So if I do the same for if k equal to 3, let's try this. K equal to 3, and here we go. So it's 5, 6, 7, 2, 3, 4. So it's 5, 6, 7, 2, 3, 4. So let's say like k equal to 4. So let's run the same thing here. So 4, 4, 5, 6, 7, 2, 3, 4. 4, 5, 6, 7, 2, 3, sorry. So 2, 3, yeah. So yeah, so this is the logic, simple logic here. And let's go and write the logic here. So I have a Python file here in my VS Code, and so here I'll be writing a function called rotate, def rotate, which will take the list. Okay, the list as argument. Let's just hard code here. So the list here is nothing but the same list which we have taken here. So yeah, I think I can. So yeah, I think it's visible. So now, yeah. So if I'm taking the list here, and I will be applying the similar logic here. So which is my indexing logic here. So I'll be getting k here. Yeah, and I'll be using the same logic here, and I'll be running my result on this and and it. Oh, so I do this and give a run here, run without debugging. An extension here. Let me find my Python extension. Yeah, let me just choose it here. Oh, just add yeah, So I set up my Python environment here and then just run the code here, run without debugging. So once if I run this code, so yeah, you can see here my result 67234. So till here it's simple, I think. So the main task comes in like if the value of k is like this. So for now we have dealt with only small values. If the value of k is what if say like 2000 times, or let's say like k, like when we write a competitive exams, so there will be like the test cases will be like 10,000 times. So they will be rotating the row 10,000 times. So what would be the scenario? So in that case, this logic won't work. So how you have to handle that thing? So the one simple thing is that so so I have not written k equal to 5 here. So the reason is that to explain this one. So if I write the k equal to 5 and 6 both. So if I write 5, so that means I will be rotating this 3 here and it will come here. And the reason I don't return this on 6 is that to explain this. So if I have rotated this 6 times, that means that you see here, I have rotated 6 times. You can see the length of L is 6 and I have rotated 6 times here and my list remains same. So we are going to use this point here to make our logic simpler. So if they ask to rotate 2000 times, we are not going to do that. So what we are going to do is we are doing the modulo of 2000 and getting the reminder there, and we'll be only rotating with that reminder. Let's say like k equal to 12. Okay, so that means that we are going to do a modulo of k, so which is 0. So that means we don't have to rotate any number of times because the k is k will be so modulo of k, and assuming that this value as k, so k will be 0, so we won't be repeating because the end of it is also that value is divided by 6, which is the length of the list, so we don't have to rotate it again. Even though if we rotate, so the list values remain same, so there is no point in rotating, so we don't have to rotate it. So that's the point here. So if for example, let's say the k is 14, so that means that modulo of k, if I do with 6, yeah, with the length of uh, let's say length of list, which is 6, here. So let's me write 6 here. Yeah, which is 6. If I do the same with 6 here, so my k, so my result becomes 2 here, which I should assume as k. So that means I have to rotate only 2 times, not 14 times here. Even if I try to rotate 14 times, this logic won't work because the k index of k will exceed this list. So we have used the simple logic and we have to simulate the number also, so that it reduces to the number of actual rotations instead of blindly taking the k value. So for that, what we need to do here is that, so whenever we get the value of k, so we just simply say like we just simply take the modulo if k mod. So let's do this like mod of k. So k modulo the length of array. So sorry, not the array list. So the length of list here, let's say my list is here, and the length of list is equal to my length of L, and this length I'm doing the modulo here, and so my condition goes like this: if the modulo of k is divided by my k, then so is divided by, that means I should get a remainder 0, then I can write down the same list. Else, that means L if, so if it is not 0, so that means, so else, but else, so the mod k, so whatever it becomes, so the k equal to, just going to override the same k value here. If it is not 0, then you're not going to, because if it's divided by divisible by the length of the list, then we don't need to rotate it. Therefore, we put it in the same list. If it is not divisible, that means we should be getting some reminder, and that reminder we are assuming as k, and we will be getting this here. So let's try the same thing with another example, like let's say I give 2 and I will give 14 here, and let's see how it goes. So uh, run here, run without debugging, right? So now that means that I should get to the required results same. So okay, the first one is okay. Okay, yeah, 6, 7, 2, 3, 4, 5. Okay, 2, 3, 4, 5, 6, 7. Okay, somewhere we have written the logic wrong. Yeah, I think we have written, yeah, so okay. So I think we have done the modulo, yeah. Yeah, I think that's the thing. Because the 2 is less than 6, right? Yeah, so if this logic only works if our length, if the k value is greater than or equal to, uh, sorry, if the k value is greater than or equal to the length of the list, so then we will assume this, or else no. So let's try it again without debugging. So now you can see, yes. So this logic, so even if I give like number, for example, rotate like 100,000 times, 100,000 times of, let's say like 600,000 times of 2. Okay. So if I do this also, we don't have to do much of that task. So it will connect some error, yeah, some error. Yeah, see, okay, why that ever came up, but yeah. So let's just yeah, so you can see here. So there's the logic. It's a simple logic here. So we're just taking the indices and eliminating what we do not want it. And so yeah, thank you. Thanks. That's all. Yeah, thank you.